Type 5 substitution method problem number 3 integral tan inverse 3x minus x cube by 1 minus 3x squared. Here substitute x equal to tan t. Now what is dx? Dx becomes secant squared t dt, isn't it? Now you substitute it here, integral tan inverse 3x 3 tan t minus tan cube t by 1 minus 3 tan square t, isn't it? That is dx is what? Dx is secant square t dt. Is it clear? This is equal to integral tan inverse. This is tan 3t secant square t t. Is it clear? This is equal to tan inverse tan t is 3t. That is 3 into integral t secant square t dt. Keep it as 1. Now you take integral t secant square t dt. Is it clear? Now you take u as t. What is du? Du is dt. dv as secant square t dt. Therefore, integral dv equal to integral secant square t, that is v equal to what is integral secant square t? Tan t. Is it clear? Substituting in the formula integral u dv equal to uv minus integral v du, we get integral u t secant square t equal to integral t secant square t dt equal to u is t, and what is v? V is what? Tan t tan t minus integral v tan t du. Du is dt. Is it clear? Now this is t tan t minus what is integral tan t? Integral tan t is log of modulus secant t dt. Secant t plus c. This is equal to t tan t minus log of root of 1 plus tan square t plus c. Now this is equal to t, substituting value of t, x equal to tan t, therefore t equal to tan inverse x, isn't it? That is t tan inverse x into tan t is x, that is x tan inverse x minus log of modulus root of 1 plus tan t is x, therefore 1 plus x squared plus c. Now 1 becomes the given integral tan inverse x, tan inverse 3x minus x cube by 1 minus 3x squared dx equal to 3 into this value, integral t secant square t dt, 3x tan inverse x minus 3 into log of modulus root of 1 plus x squared plus c. Integration by parts, Bernoulli's generalized formula. Integral u dv equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus etc., where u dash equal to du by dx, u double dash is d square u by dx squared, etc., and v1 equal to integral dv, v2 equal to integral v1 dv, etc. Here u dash, u double dash, u triple dash are successive derivatives of u, and v1, v2, v3, etc. are successive integrands of v. Problem number 1. Integral x squared e power minus 3x dx. Here you take u as x squared, then u dash is 2x, u double dash is 2, and u triple dash is 0. Now dv equal to integral e power minus 3x dx, that is integral dv, that is v equal to e power minus 3x by minus 3. Again integrate this, you will get e power minus 3x by minus 3, that is already we have minus 3, therefore this is 9. v2 equal to, again you integrate e power minus 3x by minus 3 into 9 minus 27, etc. That is integral u dv equal to this formula uv minus integral, that is u dash v1 plus u double dash v2 minus u triple dash v3, etc. That's all. Now this is equal to u is x squared, dv is what? E power minus 3x dx, that is given formula problem equal to u is x squared, v is e power minus 3x by minus 3, minus u dash is 2x, e power u dash v1 is e power minus 3x by 9, next plus u double dash is 2, v2 e power minus 3x by minus 27, isn't it? Now here you take e power minus 3x by minus 3 out, what will I get? X squared plus 2x by 3 plus 2 by 9. That's all. Integration by parts review. Here in type 1 we have integral x power n e power x, integral x power n a power x, integral x power n sin x, integral x power n cos x dx, etc. In this case you select x power n as u and the remaining as dv. Come to 2, here we have integral x power n log x and inverse functions. If we have log and inverse functions, we have to interchange this. That is, here you take u as log x and inverse x, tan inverse x, etc. and du dv as x power n dx. That is, here in the first type you take x power n as u here, whereas in the second type in which we have log x and inverse functions, we take dv as x power n dx, the remaining as u. Now second, number 2a, here the x power n is missing, integral log x, integral sin inverse x, etc. The same method, you take dv as dx and the remaining as u. The type number 3, integral root of a squared plus or minus x squared dx, integral root of x squared minus a squared dx. Here you take u as root of a squared plus or minus root of a squared plus or minus x squared and root of x squared minus a squared, and take dx as dv. Now fourth one, interesting, integral e power x sin bx dx, integral e power x cos bx dx. Here you take, it is left to you, choice is left to you. You can take either you take u as e power x or dv as e power x dx, and dv as sin bx in the first case, in the second case dv as e power x dx. It is left to you, it is as you like. For last one, substitution method, you substitute first. After substitution, any of the above method to be followed, and we are familiar with this formula. The formula is integral u dv equal to uv minus integral v du.